Okay, it's been a while since we have worked on hypergeometric and binomial, and I thought you might need a little practice, a little jog of your memory. So let's start out. Problem 1, we've got a bowl of candy. It has 12 caramels, 10 chocolate kisses, 4 slow pokes, 32 Tootsie Rolls, 7 Mary Janes. If you put your hand in and grab 5 candies, what is the probability that you will get 2 Mary Janes? Okay, well, here this might be a little bit confusing because, okay, binomial and hypergeometric both only have 2 categories, success and failure, and here it looks like I've got a bunch of different categories. But the fact of the matter is, the way I phrased the question, there is only 2 categories. It's either a Mary Jane or not a Mary Jane. Okay, because what is the probability you put in your hand, grab 5 candies, and get 2 Mary Janes? So in the way this is done, Mary Janes is success, and everything else is failure. And I put this in to be ironic because my personal opinion, Mary Janes are the most vile candy ever. Okay, they are sticky. They have a paper cover that you can't get off them, and quite frankly, the paper tastes better than the candy anyway. But all right, I digress. So what do we have here? Well, there are 7 Mary Janes to begin with. There are successes. Everything else is a failure. Okay, and so I add up all the other different types of candy, and there are 60 different types. So of the others. So I have I have A is equal to 7, B is equal to 60, and I feed the formula for hypergeometric this way. The A here, the B here, okay, the little x here, okay, the n, which is equal to 5, minus little x here, and then A plus B here, and then my sample size here. I push my calculator keys, I work the math, and I get 0.0744. Now, I urge you, when you are looking through this, to look through the associated PowerPoint with this, and to make sure that you personally can replicate all of the numbers given. Okay, calculator practice can't be emphasized. Okay, we take classes to learn how to drive a car, a piece of equipment, and it takes people years to learn how to drive a car adequately, and people want to drive cars. Calculators, quite frankly, nobody wants to know how to use them, but you still have to practice with them. So practice, practice, practice. Problem 2, okay. A bowl of candy has 12 caramels, okay, 10 chocolate kisses, 4 slow pokes, 34 Tootsie Rolls, and 7 Mary Janes. If you put in your hand and grab 3 candies, what is the probability you will get 2 Mary Janes? Verify that it is valid to use the binomial to approximate, and then approximate the answer with the binomial. And okay, we have something new here. Verify it is valid to use the binomial. Okay, what do you mean? Okay, first off, let's do the calculations. Again, as before, Mary Janes are the success, 7. Everything else is 60. We do the calculations here, okay, because we have a different sample size. Okay, it's 3. The number we get is different. Okay, now, okay, well, what am I doing here? Okay, this is not a probability, right? It's bigger than 1. Well, if we do our calculations, if we take, okay, 0.05, okay, and do our calculations and get a number, this number, if it's the right size, we will be able to do our calculations. Okay. Hold on just a second. Okay, I am not going to lie about it. You may have noticed that there was a pause in this because the teacher, had a brain fart, and I had to look up something. Okay, so what have I done here? This calculation, I've taken 0.05 times 67. Again, 67 is the sum of A and B, and I've gotten 3.5. Okay. Now, as long as my sample size, 3.35, as long as my sample size is smaller than that, it is legitimate to use this to use the binomial to approximate here. Okay. So here, this is a go. The 3 is less than the 3.35, so we can get a good approximation. So here, remember how we approximate. We calculate P, the probability of success. Mary Jane's divided by total candy gives me a P value of 1.04. Got my 3 here, 1.04, and I do my probability calculations. X equal 2. We do the run up, and there we go, 0.029, which is, okay, only 3/1000ths off of this right there, so not bad. Okay. A chicken on a particular farm will occasionally lay an egg with 2 yolks. Suppose that this happens 7% of the time. What is the probability that 3 eggs in a carton will contain a dozen that will be double yolked? Okay, now, just as a point, I had a student in class one year that had chickens. You know, we're in Pittsburgh, Kansas, had chickens, and she brought me a dozen eggs from them. You know, so if you feel so moved, you know, I do eat eggs. Anyway, so here we go. What sort of problem is this? This is a binomial problem because you have 7% of the time you've got a success. Okay, just a pure binomial. So we have the sample size of 3. What's the probability you'll have 3 double yolked in that? Well, you do the calculations, feed the problem, and only about 4% of the time would something wonderful like that happen. If I get 3 double yolked eggs in a dozen. Okay, problem 4. A gumball machine contains 200 red gumballs, 100 white ones, 75 blue ones. A 10-year-old boy buys 4. What's the probability that one will be red? And I have to admit, throwing in the 10-year-old boy is just being mean, because somebody, I guarantee you, is going to try to use that 10 somewhere in this problem. Okay, this is hypergeometric. Okay, we have 200 successes, right, because they were 200 red gumballs. We're asking about the probability of red. Everything else together, 175, and have us taking a sample size of 4. What's the probability that all 4 of them will be red? Well, doing the calculations, we find it to be very small. Okay, 0.08.